Alright, in this video I will be solving quadratic equations such as these using the quadratic formula. Alright, I am going to start with number 40. But first of all, let's pause and remember the quadratic formula. It goes like this. If we have an equation of the form ax squared plus bx plus c equals 0, the quadratic formula says x is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, now I wrote this part in pink because it has a special name. It's called the discriminant. And when you're doing the quadratic formula, you should always calculate the discriminant first before you do the rest of the problem. So that's what we're going to be doing. So first of all, let's go ahead and subtract 14 from both sides. Alright, so right away that's going to give us x squared minus 5x minus 14 is equal to 0. Alright, because notice to do the quadratic formula we need 0 on one side. That means a is 1, b is negative 5, and c is negative 14. So let's go ahead and do the discriminant now. The discriminant, b squared minus 4ac, that's going to be negative 5 squared minus 4 times 1 times negative 14. Notice how I put the b value in parentheses. Make sure you do that. So it's minus 4ac. Whoops, that's supposed to be negative 14. Now, you didn't really need to put the 1 because 1's not going to change anything, but I don't want to confuse anybody by skipping steps, so I just typed in the whole thing. Alright, it turns out to be 81 is my discriminant. Okay, so the discriminant is 81. So now I will go ahead and do the rest of the quadratic formula. So x is equal to opposite of b, right? So if b is negative 5, then that's going to be positive 5 plus or minus the square root. And now the 81 is going to go right here. All right, that's our discriminant is right here, all over 2a. Well, 2a, a is 1, so 2a is just 2. So I have this. Now, 81 is, of course, a perfect square, so that makes this 5 plus or minus 9 over 2. All right, well, it's time to go ahead and split this apart into the two solutions. Because I can do 5 plus 9 over 2 or 5 minus 9 over 2. That's what plus or minus means, plus 9 or minus 9. So 5 plus 9, that's going to be 14 over 2, or, and 5 minus 9, that's going to be negative 4 over 2. So that's going to give us 7 or negative 2. Alright, so that is how you solve using the quadratic formula. Alright, let's take a look at number 41. Again, the first thing we will do is calculate the discriminant. Alright, so that's b squared minus 4ac. Alright, so that is negative 36. right, so that means the solution is going to be opposite of b, so that'll be negative 2 plus or minus the square root of negative 36, all right, there's my discriminant, all over 2a, well a is 1, so that'll just be 2. All right, that's interesting. So I have a negative under a radical. What happens when you have a negative under a radical? That's imaginary. So this is like I radical 36. Now without the negative, the square root of 36 is 6. But because there's a negative under there, it's going to be 6i. Okay? There is a little bit more we can do. We cannot add negative 2 and 6i. But all three of these are divisible by 2. So it would be helpful to do this. And sometimes I put a heart around the coefficients to remind me that it has to be all three or nothing. I couldn't just say cancel out the 2's and not do anything with the 6. All three of these are divisible by 2. So I'm going to divide all three or nothing. If I divide all three of these by 2, then I get negative 1. And here I get plus or minus 3i. Okay, and 2 divided by 2 is 1. But we don't put a 1 down in the denominator by itself. So this is the final answer for number 41. Okay, one more. Again, before we get carried away, we need to subtract 4 from both sides. So that's going to give us 2x squared minus x minus 4 is equal to 0. Okay, so let's calculate the discriminant first, like you do. B squared minus 4ac. B is this negative 1. So it's negative 1 squared minus 4ac. 33. All right, that's my discriminant. So now I will finish the quadratic formula. So opposite of b. So b is negative 1, so the opposite of b will be positive 1. So I'll have positive 1 plus or minus the square root of my discriminant all over 2a. Well, 2a is 2 times 2, which is 4. And look, this is a radical that can't be simplified, so I can't add. There's no common factor looking at the coefficients, so I'm done. This is as far as we can go with this problem. We just stop. All right, and that was the last problem.